Hi chemistry students, today we're going to learn how to do chemical nomenclature. I've got a few examples behind me here that I thought I would walk you through and see what you think. Chemical nomenclature is the systematic method of naming and writing formulas for compounds. So here are 4 compounds that I think are interesting in the way their names and formulas work. First we have CaCl2, that's calcium chloride. Then we have CF4, that's carbon tetrafluoride. Then we have FeSO4, that's iron, Roman numeral 2, sulfate. And lastly we have HCl, which is hydrochloric acid. So you might be wondering at this point how those things relate. It almost seems to make sense some of the time because, for example, the 4 here in CF4 goes with tetra, that prefix. And yet there's a 2 subscript here and no prefix in calcium chloride. And there is a reason for that, and by the end of this unit you'll be able to understand the reasons for that and use the chemical nomenclature rules to write names and formulas for all kinds of compounds. Hi chemistry students, today we're going to do an introduction to naming compounds and writing formulas. This is for a unit called chemical nomenclature. And you already know that there are 2 major types of bonds that we talked about, ionic and covalent bonds. And because of that, there are 2 major types of compounds as well. So ionic compounds are formed from a metal ion and a nonmetal ion. Metal and nonmetal is ionic, just like before. And molecular compounds are formed from 2 nonmetals. And here we have, again, a reminder of where the metals and nonmetals are found. The metals are pink and the nonmetals are blue. And the green guys are a little bit tricky, but I drew the staircase in here so you can decide whether something is a metal or a nonmetal. And that's, for naming compounds, that's a hard line. We don't cross that line. So like aluminum is definitely a metal and silicon is definitely a nonmetal when it comes to naming compounds. Now silicon does have some properties where it will behave sort of in a metallic way, but not exactly like a metal. So it is a metalloid, but for naming compounds, we're going to separate those 2 completely. The 2 types of compounds are assigned names and formulas in very different ways. And on the board behind me, I've got some examples that I thought I would show you so that you could get a feel for this. So here we have CaCl2, that's called calcium chloride. The next one is CF4, it's carbon tetrafluoride. Then we have FeSO4, that's iron 2 sulfate. And then HCl is called hydrochloric acid. So as you can see, the name doesn't always directly tell you what the formula is. So it's a little bit tricky, and you've really got to learn the 2 different ways that we assign names. So 2 different systems of naming, they're almost completely separate from each other, and that's a little confusing at first. Students sometimes get frustrated with this unit because they really have to think for each question, am I dealing with an ionic compound or a covalent molecular compound? So again, you have to learn which system you're going to use. For each compound, before you write the name of the formula, you ask yourself the one most important question, which is the first element a metal or is it a nonmetal? And the reason I say first element is because by tradition in chemistry, we always write the most metallic element first. So if the first element is not a metal, then there's not going to be a metal in it. So this is what you need to write down. If the first element is a metal, then the compound is ionic. The name does not use any Greek prefixes, and it might have Roman numerals in it. And the formula may have subscripts that are not mentioned in the name. You can pause and write that down if you'd like. If the first element is a nonmetal, the rules are totally different, whole different set of rules. If the first element is a nonmetal, this compound is molecular. And the name does include Greek prefixes, and it does not ever include Roman numerals. You won't have Greek prefixes and Roman numerals together ever. And the formula is going to have subscripts that are indicated by the prefixes. Most kids find these molecular compounds are a little bit easier to write the formulas or the names for. and I'll show you why with some examples. So again, here are your 10 Greek prefixes, and you do need to write these down. 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona or nona, and 10 is deca. And you do need to have those memorized, and again, they apply only to molecular compounds, compounds that start with a nonmetal. Again, if the first element is a metal, then the rules are totally different, and we're back to the ionic compounds. So you really have to keep those clear in your mind. It's a bit of a challenge, but if you remember to ask yourself that question, is the first element a metal or not, then you'll be in good shape. Most important question, is the first element a metal, or is it a nonmetal? Once you've decided ionic or molecular, there is one more step that you need to take before you can name your compound. If it's ionic, you must count the elements in the formula. If there are 2 elements, it's a binary ionic. If there's more than 2, it's ternary ionic. Binary means 2, ternary means more than 2, 3 or more. If you're looking at the name and trying to decide on the formula of something, sometimes this gets difficult. Because if you're looking at the formula, for example, this one, FeSO4, you can see that there's Fe, iron, there's sulfur, and there's oxygen. So there's 3 elements, so this is ternary. But what if you only had the name to look at? Well, it would be hard to tell if it was ternary in that case, but there are some clues. If it starts with ammonium, the word ammonium, or NH4 in the compound, or if it ends with ate, like sulfate, or if it ends with ite, or if it ends with cyanide. Let's get this guy out of the way here. There we go. So those are easy ways to figure out when you're looking at a ternary compound. To review, before you can name the compound or write the formula, you need to decide if the compound is molecular, that's 2 nonmetals, or if it's binary ionic, a metal and a nonmetal, only 2 elements, or ternary ionic, metal and nonmetal, 3 or more elements. So sometimes we'll abbreviate these M for molecular, Bi for binary ionic, and Ti for ternary ionic. So we could do that with these real quick. Calcium chloride, calcium on your periodic table you'll know is a metal. And since it starts with a metal, this is ionic. And because it doesn't end with ate or ite or start with ammonium, we're looking at a binary ionic compound here. You can also tell because CaCl2, CaCl, that's it. My bird clock is making noise. It's woodpecker o'clock over here. Sorry about that. Binary ionic for calcium chloride. Carbon tetrafluoride. Carbon is a nonmetal, so we're looking at a molecular compound. Iron 2 sulfate, we already said is ternary ionic. Iron's a metal. It ends in ate. And then hydrochloric acid has only hydrogen and chlorine, which are both nonmetals. So this is a molecular compound, but it is a separate class of molecular compounds, the acids. And we'll talk about how to write acid names later on. And that's it for today.